Hello again, and in this video this time we're going to deal with Microsoft Fabric but from the Apache Spark point of view. If you have seen my previous video, we did this with T-SQL and showed you how to deal with files and tables. Very easy way to deal with your data for analytics inside of Microsoft Fabric. For this one, if you're a data scientist, for instance, we'd like to treat your data and transform your data and work with it from an Apache Spark point of view, you will feel right at home as well. So let's go ahead and get started. So again, once you log into your system by going to app.fabric.microsoft.com, notice at the bottom left in here the Microsoft Fabric logo. If you click on it, I'm going to go with data engineering for right now. And again, I'm going to go ahead and I can create my own workspace, or I can use the one that's called My Workspace that got created for me automatically. You can have multiple workspaces if you want, that's not a problem. And in this case, I'm going to click on Lakehouse. We always start with a Lakehouse where we bring in some data and get it ready to be worked on, whether it's with T-SQL or notebooks using Spark jobs and so on and so forth. So I'm going to click on the Lakehouse. And from this point, we'll give it a name. We'll call it, for instance, Lino House. There you go. Lino House. And we'll say create that Lakehouse. All right. The next step would be for me to find some files here locally on my machine. And I have a folder called orders that contains 3 different CSV files for sales and orders from 2019, 2020, and 2021. Let's go ahead and see that. I don't have to actually go here to files and upload them one by one. I can say upload folder, and I can upload the whole folder all at once. So I'm going to say upload the folder. We'll locate that folder on my hard drive. I believe I put it under the downloads. Let me bring this up. Downloads, and oh, there it is. There's a folder called orders in here. We'll say upload, and hopefully once we upload the 3 files, there you go, the 2019 CSV, 220 and 221 will be uploaded here in a few seconds, and we are done. So now hopefully when I open up the files in the Explorer in Microsoft Fabric, you will see the orders folder, and if I click on it, my 3 files in here, and we are in pretty good shape. Just to make sure that everything is correct in here, just click on one of them and you will see a preview loading in here. Notice something, there is no header in here, and that's important for you to know as well, because once we bring that to Spark, for instance, we will need to change probably the command to let it know that there are no headers. Maybe I need to give it my own schema to make this work well. Make sense so far? Of course, I want you to remember that if I decided to go to one of my tables, let me go back to orders in here, I can do what I did before in a previous video by clicking in here and saying load to tables, and then I can T-SQL into it and all that. That's still available for you. You can even use Power Query like you're used to in Power BI. You can do all that. But in this point, I would like to deal with that directly in Spark. So I'm going to go click on Home again. And notice here I can create a brand new notebook. Let's click on Notebook. And that will open up a notebook automatically here in my working area, in my workspace. And what you'll be faced with is one cell just having some markup in it. You are more than welcome to delete that and start writing your code, or you can be nice and actually give some documentation to the rest of your team. Let them know what each cell is about to do, so you can write this as a markup in here. All right. One important thing I want to mention as well, the default inside of Microsoft Fabric is to use Spark, Python. So PySpark, that's a special Python specifically for Spark for optimization and so on. But Python is pretty much the default. But if you go here on the right side, you can see all the languages that you can use. You can use PySpark, which is the default. You can use Scala by saying Spark or Spark SQL. You can use the R language as well if you would like. All of these are available. And there might be more in the future as well. Again, this is in preview as of right now. In the future might be more that you will have in here as well. And if you're familiar with notebooks, you can actually use the magic command, which is %%. So even though your notebook is based on Python, maybe 1 or 2 cells I need to use Scala, for instance. So I will say %% Spark in the beginning of the cell, and that will only executing the Scala engine on this cell alone, and then it will go back to PySpark, which is Python. So you can use the magic command like you're used to in every other notebook probably that you have used before. Remember also that in the previous step I created something called the Lino House, which contains my data. So I can add it here to the Lakehouse Explorer, so I can use it directly in my notebook. So we'll say add existing Lakehouse. And there is my Lino house in here. We'll say add, and now I will have access to it. That will make it easy so that I can right click on the orders. For instance, let's go ahead and open up this guy in 2019, and notice here I can say load data. If I've done this correctly, if I say load data, I can do it in Spark, and I can use the pandas libraries if I want to. I'm going to say for Spark right now, and the code will be loaded for me here automatically. Just remember, I did this only on one of the files, not all of them, just the 2019 one by itself. So the code that got created for me from loading that into a data frame, df is the data frame that I'm creating, is reading from a CSV. It was able to figure that by itself. Unfortunately, it says header equal to true. That's the one built in, but we will see what will happen when I do header equal to true, even though I opened the file and I showed you it doesn't have a header. But the loading of the files coming from orders folder under files 2019.csv. And I can display that. So I can actually click on the run button right next to it, or I can say Control Enter or Shift Enter to be able to run the cell based on your preference, whether you like to use the keyboard or the mouse to run a specific cell. So let's go ahead and run it. And the first time you do this, it might take a little bit of time, but maybe hopefully less than a minute. That's because it's going to actually require a cluster to be running to make all the stuff running. It's only the first time to wake up pretty much the cluster that this will run serverlessly. So Apache Spark right now started, didn't take much time. Only 10 seconds to be able to do that. That's excellent. If you're familiar with Spark, usually that takes a significant amount of time to do it on your own. But if you use Synapse or Databricks or now Microsoft Fabric, it's way optimized and way faster to start the cluster to be able to run your notebook in there. And that is the data I can see in here. But notice there is something bad in here. It took the first record in the CSV file and made it the header because I told it header equal to true. So there's obviously something wrong in here, so I need to fix that. So let's go ahead and fix that together. So I'm going to go back here when it says true, and I'm going to enter false on this one, and let's go ahead and run it one more time. All right, this one is better. So I have all my data. That's great. But again, the headers are going to be just column 1, column 0, column 2, and so on. So I need to give it a little bit of a schema to explain exactly what each one of these columns is all about. So let's go ahead and do that and try to clean this up a little bit more. And maybe instead of just doing all that by keep replacing the same cell, let's go ahead and create another cell. Maybe that would be better for us to do that. So if you actually go all the way to the bottom in here, there is a second cell. And notice something that will show up here which says I would like to add another cell of code or maybe a markdown. They will show up in here to help you out with that. So I'm going to click in here. Let me bring in some code and explain it a little bit. So first of all, I'm going to import the library. This is to bring in all the types of SQL. So I can actually be able to tell you if I want a string type, an integer type, date type, and so on. So you will be able to define the struct types in the SQL by importing the SQL types on PySpark. I'm importing everything in here, and notice I'm creating maybe 6 or 7 different columns and giving them names and tell them what type I would like based on that. And instead of having our line of code that says read the format CSV and header equal to true, this time notice I'm doing my data frame by telling read the CSV file, but I would like to use a schema, and the schema will be the order schema that I created over here. And I'm going to go ahead and tell it load from the 2019 and show me all that stuff as well. So let's go ahead and run this cell and see if it looks even a little bit better than before. And it is a little bit better. It's the same data, but now I have column headers that has the sales order number, the order date, the email, and everything. So it's a much better shape. And I've done all the stuff in my Python code right in here in Microsoft Fabric. And maybe I don't need all of these different columns from the data coming from 2019. So let's go a little bit down in here and click on code, for instance. What happens if I do something like this? I'm going to bring in some code. I'm going to create a brand new data frame, and this data frame is going to load the DF, the current one, but I'm only going to choose 2 different columns from there, the customer name and the email. And this is not the only way you can do. This is just a shortcut by saying df and open up an array and specify the name of the column. You can still say df.select and pass that as a function with the names of the columns that you want. But this is a quick way of being able to define which columns you're interested in. And notice here I'm doing a couple of prints, once to get you the count of the new data frame that I'm creating, or a distinct count, or I can actually display also the customer.strings all at once. So let's go ahead and run this and see what we will get out of that. It's running that in the cluster as a Spark job, but notice here I will be able to see the customer name and email. I don't get any of the other columns, and it's displaying that based on the customer distinct. And also there are two numbers in here. See the 1201? That's the customer count, to 1,201, and the distinct. So I don't have any duplicates based on the customer name in here as well. And it actually did this based on splitting that between 7 different jobs, and they all succeeded to be able to give you that result that you're looking at. And you can always open up the results from every cell and see exactly each job, how it was actually executed, how long it took to execute, how much data came back, a lot of information. You can dig deeper and deeper into every single job to find out what exactly happened on each one. So it's a great for monitoring and understanding, but some of these jobs will take significant amount of time if you have petabytes worth of data, so you can monitor what's going on and where is it stuck, or what you can do to make it better, and so on and so forth. What if I would like to run the same thing but with a where clause? I want to filter this on a very specific item that I'm interested in. Let's go ahead and add another code cell in here. And this time, instead of just selecting the customer name and email, I'm going to say where the data frame itself, item column has a value of row 250 RD52 for the item name itself. So let's go ahead and run this one. And instead of going to be 1,201, notice it says 0. I don't have any of the stuff in the database right now at all. Okay, maybe we can fix that. Instead of row 250, let's go ahead and make it 150. I think that's the name of the item, and we'll go ahead and run it one more time. All right, great. This one has 155 distinct items that are called row 150 red 52 in there, and I will have the display of the distincts in here. I can see them all in the system. So you can see that I can actually create data frames from data frames that are filtered, and from that point on, the customer data frame will only contain the 155 item inside of it and keep going from there. So it actually you can keep going based on that and start using customers and other functionality, and you will know that it only contains 155, not the 1,201 anymore. Another thing that I can do is aggregation. So let's go ahead and add another code in here, and I'll show you, for instance, if I want to do a new data frame called product sales, and this time I'm going to use item and quantity. I'm going to group them all by item, and I'm going to do a sum aggregation on all of them, and let's display the new data frame from product sales. Let's run this. So you will notice that it knows how to do the sum and the sum quantity in here, as you can see, for every single item coming in from this data set as well. Another thing I wanted to show you, what if I want to use some functions? That's a different import from the PySpark SQL functions. So far we have used the SQL types, but SQL functions are available for aggregation as well. So I'm going to remove these two lines, and instead I'm going to import the SQL functions from the PySpark, and then I can actually use functionality like year, and I can actually be able to actually almost pretty much creating a brand new column for the year inside of this yearly sales by selecting a year function order date to extract that from it, and I'll give it an alias for the name of the column year, and I will group by that year and do the count year by the year column itself. So you can do it on the fly, so that even though year does not exist, I'm creating this on the fly using a function. I can use it in the rest of the group by and the count and the order by and so on. So that's very, very powerful to be able to do something like that. Let's run this one more time and see if it will work. And you will notice here the grouping and the year by for 2019, we have 1,201 is the full count. So the year here is a brand new column pretty much that I created on the fly using functions from PySpark SQL. Another thing I can show you probably is the chaining. So let me go ahead and do functions with chaining. This is very, very valuable for transformations that you can do it in Spark as well. So I am going to import the SQL functions in here from PySpark as well. And look what happens in each and every single one. So the first one, I'm creating a brand new data frame called transform df. And I'm going to use the existing df that contains everything. And I'm going to say with column, I'm going to add a new year. So I'm adding a year and a month, okay? And I'm going to create that based on a new column in the data set called year on the fly. And I'm going to use one for month as well. And then I'm going to take whatever transform df gave me from line number 4 in here, and I'm going to actually override it. I'm going to create the same name, transform df, but I'm going to override it by actually splitting the name customer name, it contains the first name and last name with a space in between the two. So I can actually create two different columns, one for the first name and one for the last name. So again, this is a very simple thing to do in Spark by actually getting into creating two new fields. One is called first name, one is called last name, but you'll notice it's doing a split here, and the split will have the space in between them that it will split on it to be able to take one column and split it into two. The one column is called customer name, and I'm creating first name and last name out of it as well. I can also do filtering and reordering of the column as well. So I can still use the same exact name. So I'm overriding my current data frame, and I'm actually choosing the sales order number, the order line number, order date. Now I'm including my year and my months, first name, last name. All that will be part of the new data frame, and then I can display it. So let's go ahead and give it a shot and see if all these transformations happen correctly in my data set. And as you can see, it did work. Now I have year and I have months. And if I go to the right a little bit, first name and last name has been split correctly. So I can actually transform my data however I want with only one line of code on each one transformations. That's how strong Spark is, and it's being used heavily. So data scientists like to use this, and they're used to it, and you are more than welcome. It's a first-class citizen inside of Microsoft Fabric to do that anyhow. And really the final piece I wanted to show you is what happens when I want to save this. So this is something I've been working on. I did a lot of my transformations. I want to save this so the rest of the team actually in my lakehouse can use this cleaned up and transformed data as well. So let's create a brand new cell in here for the code. And I'm going to bring in some code in here. We'll say the name of the data frame, which is called transform df. I'm going to say write mode overwrite, and I'm going to write it to Parquet files. And I'm going to put it under the files folder in here, but I'm going to create a brand new folder called transform data /orders. And now I'm going to go ahead and show you a printout that says it has been transformed already. But if this succeeded, the print will happen, and I know now that we will end up getting a brand new folder with a brand new Parquet file that contains the transformed data as well. Let's go ahead and run it. And there you go, there is a Spark job that got created, and the print happened, transformed data saved, there was no errors, so we are in a pretty good shape, and it should work from that point on. And sometimes, again, remember we are still in preview. That new folder and that new Parquet file might not show up right away, so sometimes you have to go to files and click on the ellipsis button and say refresh. And if we do refresh, then the folder will show up. There is my transformed data in here. There is the orders underneath it. If I click on it, there is the new Parquet file in here as well with a snappy compression that contains the data that has been transformed. And it's ready now in the lakehouse for anybody who want to use it, whether in T-SQL, whether you want to use it in Spark still, or you want to use it in Power Query. They're all available. That's the beauty about having a unified system like this, that you can create something in Spark and the meta store will allow it to be available for everybody else that want to use it in the system. Hopefully that was useful to you. Just we spent about 15 minutes together to show you that you don't have to do it in SQL or Power Query. You can do it like you're used to maybe as a data scientist in Spark, and the system is very powerful, and the notebooks will actually allow you to write code in multiple language, and you'll be able to do whatever you're used to with Spark or Panda libraries and so on and so forth to be able to transform, clean up the data, and get it to a curated settings that will be available for Power BI and maybe AI and machine learning in the future as well if you'd like to work on a transformed data. But the system is working for whatever tool or technology you are accustomed to, and it will work with you. Hopefully this was useful to you, and I'll see you again in a future video really soon.